Hello, everyone, and welcome to today's talk, Actionable Ethics for Data Scientists. My name is Cassandra, and I'll be your moderator. We're very excited to be hosting this session, and I'm pleased to introduce today's speaker, Emily Miller, a data scientist at DrivenData. Before we begin, I have a few housekeeping items to cover. We'd love to hear from you during today's presentation. If you have a question for the speaker, please feel free to send it through the question box on the control panel. As a quick reminder, a brief survey will follow the end of this session, and we would really appreciate your feedback. We love data too. So without further ado, Emily, the floor is yours.
Hi, everyone, and welcome to today's section on actionable ethics for data scientists. I'm Emily Miller, and I'm a data scientist at DrivenData. So DrivenData is a data science and machine learning consultancy in the social good space. So this means that we work with nonprofits, NGOs, governments, and socially minded private sector companies to help them leverage the power of data science to maximize their impact. We do this through direct client engagements, as well as through hosting online data science competitions in the social good space. So if you find yourself with some extra time on your hands right now, and you want to try to win some prizes or just build your skills working on meaningful data sets, I encourage you to check out drivendata.org and take a look at the competitions that we're currently running. We just released a competition this week on predicting flu vaccination rates using sociodemographic and behavioral characteristics. So apart from our direct client work and our data science competitions, we also devote some time to developing open source projects. And this is our way of also giving back to the data science community. So I'm going to talk about one such project today that's focused on data ethics. So here's the plan for today. We're going to start just with a quick introduction on what data ethics is and why it matters. But we're going to spend most of our time talking about an actionable approach to data ethics. And for this, we're going to use Dion. Dion's a tool that we built that lets you easily add an ethics checklist to your data science projects. So I'll give you a bit of a perspective on why this is structured as a checklist and some of our perspectives in building this tool, but we'll really spend most of our time today talking through the checklist content itself. So the checklist is not going to give you simple answers. It's not going to tell you to remove variable X from your model. Rather, the checklist is really structured as a set of questions to help illuminate the different ethical concerns that come up throughout the data science process. So a lot of conversations that I've heard about data ethics really serve to reinforce that data ethics is important, but don't necessarily tell us what we should be doing about it. So our goal with Dion is really to give you a concrete way forward, right? A way of spotting the different ethical considerations that are at play so that you can be really intentional in the choices that you're making and preemptively address issues that might otherwise get overlooked. So I encourage you to send questions throughout the chat. You can do this through clicking the question mark icon on the right-hand side of the panel. These will go to me. I'll try to monitor those throughout, but we'll also save some time at the end for Q&A. So let's dig in. Ethics. We're not going to dig too deep into philosophy today, so we're just going to use the dictionary definition, and that defines ethics as the moral principles that govern a person's behavior or the conducting of an activity. So when we think through ethics, right, it's important to remember that ethics is hard, right? It is full of nuances and trade-offs, and as economists like to say, there's no free lunch. As you're discussing this on your teams, it's also important to remember that reasonable people can disagree, right? There's oftentimes not one right answer. Thirdly, and if you take away one thing from this talk today, let it be this: good intentions are not enough, right? I'll say that again, good intentions are not enough. We must intentionally consider the consequences of our choices. So today, I'm not going to tell you the right answer or what you should do, right? But I will give you a practical starting point for incorporating ethics into your data science work. So a little bit on why does data ethics matter? So there's no shortage of articles telling us that data is important, right? Data has been called a more valuable resource than oil. Data scientist, as we all know, has been called the sexiest job of the 21st century. And so we see data impacting industries across the board, right? From healthcare to the criminal justice system. And what we have to remember is that as data use becomes more widespread, so do the impacts of how data is handled and how algorithms are designed. And so we've already seen cases where algorithms have gone awry, right? Well-intentioned algorithms have perpetuated biases and systemic inequalities. And so I think that we can agree that incorporating ethics into data science, machine learning, and AI is increasingly important. And yet so many conversations about data ethics are theoretical and vague, and it makes it really hard for practitioners to understand what does this look like on a day-to-day basis, right? How do we actually incorporate this into our work? So the place that we started from at DrivenData was how can we help data scientists engage with data ethics in a more actionable and practical way? And so for this, we built Dion. And Dion is an open source command line tool that lets you easily add an ethics checklist to your data science projects. So let's break down what that means. So first, an ethics checklist. I'd like to just say this is inspired by previous work, especially of oaths and checklists by Mike, Hilary Mason, and DJ Patil, who've really done a lot of great thinking in this space. So checklists are great for many different things. The first thing they're good at is connecting principles to practice. Checklists excel at connecting big picture ideas into everyday tasks. Checklists are much more specific than oaths as well, right? Oaths can be quite vague, such as do no harm. Checklists, on the other hand, are designed to be actionable, right? They're specific, they're focused on execution, and they're used repeatedly. Finally, checklists help ensure that we don't overlook important work, right? They give us reminders, and they help us embed these ethical discussions into our workflow so that they happen even in fast-paced environments. So by now you might be thinking, okay, an ethics checklist sounds helpful, but why did you make this a Python package, right? Why didn't you just make this a Word document and leave it at that? So the reason why we made this into a Python package is we really wanted to keep data scientists in their normal workflow, right? We wanted to keep them working at the command line, in text editors, in Jupyter notebooks. And so the fact that this is a pip installable package makes it really easy to integrate into your normal workflow. It makes it scriptable, right? So you can include this in your bash RC or makefile that's run at the start of the project. And it's also customizable. It makes it really easy to pass in a custom checklist that captures the domain-specific concerns for your team. So at the start of the project, it's really easy to generate the checklist, right? And then submit a PR with it to your project repo. This is a great way to start the conversation on your team. And then the checklist is then in the repo for everyone to interact with so that you can track changes and you can have these discussions and you can see how they're progressing over time. It may also be the case that you're not working in a project repo and you're just doing a standalone analysis in a Jupyter notebook. We also make it possible to just output the checklist directly to a Jupyter notebook so that you can interact with these different ethical concerns as you're doing that analysis. So we support various file formats, Markdown, HTML, a Jupyter notebook, among others. So the Dion is really easy to use. It just takes 2 lines of code. First, you pip install it, pip install Dion, and then you output the checklist to the file of your choosing. So before we dive into the checklist content itself, I just want to share a few more perspectives that we had in building this tool. So the first is that our goal is not to be arbitrators of what ethical concerns merit inclusion, right? This is not intended as a one-size-fits-all approach. Rather, this is meant as a sensible starting point, right? A reasonable default that we think captures a number of cases across domains. But we definitely believe that teams will benefit from building custom checklists. Secondly, checklist items are meant to provoke discussion. Right? The goal of the checklist is not to recommend specific actions, but they're framed as prompts to discuss or consider. You'll notice as we go through that a lot of checklist items begin with, have we considered, have we tested, have we thought about, right? They're really to spur these discussions so that we can weigh the different trade-offs and nuances and have these hard ethical discussions that are needed in each of these areas. It's also worth mentioning that decisions on the ethical course of action are not up to data scientists alone, right? But this checklist is designed to provoke conversations around issues where data scientists have a particular responsibility and perspective. But these conversations should happen within a larger organizational commitment to doing what is right. And finally, strictly statistical best practices are not included in the checklist. This is really meant to go above and beyond statistical correctness. So the checklist is broken up into 5 sections: data collection, data storage, analysis, modeling, and deployment. And the reason for this is that there are different ethical concerns that arise at different points in the data science process. Actually, one other thing I'd like to say here is that your project may not include all 5 sections, right? You might not be doing any data collection for your project, or you might not be deploying a model. And so it's totally okay to have NA be the answer for a section or even certain items that just don't apply to your project. This is really intended to cover that full life cycle. So one of the things that we did when we put together the documentation for Dion is we created a table of examples that have real-world examples tied to each checklist item that show times where things have gone wrong. And we found this to be really helpful in making the concepts on the checklist more concrete and easier to understand. So all of the examples that I'm going to talk through today are available on dion.drivendata.org/examples, and so I encourage you to check that out. So now I'm going to go through the different items on the checklist, and I'm going to root each section in an example to help illustrate where having an ethical discussion might have helped provide a course correction. So we'll start with data collection. The first item here is informed consent. If there are human subjects, have they given informed consent? And by this we mean having subjects affirmatively opt in and having a clear understanding of the data uses to which they consent. So informed consent is really important to avoid exploitative relationships. Second, we have collection bias. Have we considered sources of bias that could be introduced during data collection and survey design and taken steps to mitigate those? So there's a lot of literature, statistical literature around how to design a representative sample. And what we need to remember is that even with our best efforts to design a representative sample, we're still going to have bias in our data because there are certain things that we can't capture, or even potentially bias that we've introduced based on the way that we've asked questions. So we want to really think about what aren't we seeing in our data, as well as what biases have we inadvertently introduced. So if we had a question on gender and there were 2 potential answers, male and female, then we've now inadvertently excluded a portion of the population that identifies as non-binary. Thirdly, we have limiting PII exposure. So this one says, have we considered ways to minimize exposure of personally identifiable information? For example, through anonymization or not collecting information that isn't relevant for analysis. So here we want to think about what is the level of information that we need. If we don't need names and emails and phone numbers, then we shouldn't be collecting that, right? If it's not relevant for the analysis, we should not be collecting it. And if we do need it, then we need to think carefully about how do we properly anonymize this. So to give you an example of where things have gone wrong, I want to talk about collection bias here, because collection bias is sometimes harder to spot with passively collected data, but even more important. So this example comes from an app called Street Bump. And the idea here is that this app would passively detect potholes based on your phone's GPS and accelerometer data. And in theory, this would detect potholes, and that would allow the city government to direct public resources in a more data-driven way. And so on the surface, this sounds great, right? It's a data-driven use of decision-making. We're not bothering people, we're just collecting data passively. But we have to think about who is likely to have smartphones, right? And in areas that have lower income populations or more elderly populations, smartphone penetration is likely to be lower in those areas. And so the result of this can actually be a diversion of resources toward younger and richer areas, not necessarily because they have more potholes, they're just more likely to have the smartphone that enables them to capture that data. So moving into data storage. The first concern here is data security. And this asks, do we have a plan to protect and secure data? And it's going to come as a surprise to no one that data security is really important. And by this, we're talking about things like encryption at rest and in transit, access controls on internal users and third parties, having access logs, and up-to-date software. Secondly, we have the right to be forgotten. Do we have a mechanism through which an individual can request their personal information be removed? So this is particularly important in light of GDPR, which includes the right to data erasure. And what that means is that it gives an individual the ability to have their data be erased and to halt third parties' processing of their data. I just got a question about how to access these slides. These slides will be shared after the webinar on the ODSC site. And also, so much of this information is also on dion.drivendata.org, and so I encourage you to check it out there. So let's see, so that was right to be forgotten. So the next item here is the data retention plan. And this asks, is there a schedule or a plan to delete the data after it is no longer needed? So here we want to think about how long do we actually need the data to be around for, right? We don't want to keep data that we're not working on or not using on our computers because this just exposes us to, avoidable data security and privacy breaches. So to talk about an example of data security here, I'm going to talk about Equifax. So Equifax, for those who aren't familiar, is in the business of assessing creditworthiness. So if you take out a loan to buy a house or a car, the lender is going to go to Equifax to figure out if you should get that loan and what your interest rate should be. And so since Equifax is in the business of determining creditworthiness, they have a ton of PII, right? They have past addresses, social security numbers, driver's license, salary data, tax data, you name it. And so what happened back in 2017 is that hackers exploited a simple website vulnerability and then stole the personal and financial data from more than 146 million people, which was a breach on record scale. And the important thing, or one of the interesting things here, is that after the hackers exploited that first vulnerability, they essentially gained the keys to the kingdom, and that's what allowed them to steal data on such a large scale. And so here we'd really want to think through, right, the multiple layers of control, especially given how much PII Equifax has. So moving into the analysis bucket, this is one of my favorites because there's a lot of really good stuff in here. The first item here is missing perspectives. Have we sought to address blind spots in the analysis through engagement with relevant stakeholders, such as checking assumptions and discussing implications with affected communities and subject matter experts? So this one's really important for us at DrivenData because we work across a large variety of industries. We work in healthcare, financial inclusion, energy efficiency, conservation work, right? And we're not experts in all of those areas. And so it's really important as we go through our analysis that we're working really closely with subject matter experts, recognizing our blind spots and really making sure that we're defining things properly, that we're interpreting things correctly, right? That we're checking implications of this work to really make sure that our analysis has the impact that we intend. Next, we have dataset bias. Have we examined the data for possible sources of bias and taken steps to mitigate or address these biases? So it's important to remember that no matter how much work we've done in our data collection and our data cleaning, our data set will always be biased. So the question to ask is not, is my data set biased, but how is my data set biased? And so by bias, we're talking about things like stereotype perpetuation, confirmation bias, imbalanced classes, or omitted confounding variables, to name a few examples. We also want to think about honest representation here. And so this has to do with data visualizations. And personally, I love data visualizations. I think they're really powerful. They're just way more interesting to look at compared to a table of numbers. But those who design data visualizations have a great power as well as a great responsibility. And so we really need to be asking ourselves, Are our visualizations, our summary statistics, and our reports designed to honestly represent the underlying data? And so this isn't just about, are we not misleading people, but are we using visualization properties in an intuitive way, right? So let's not use a dual axis chart where a single axis is sufficient, right? We want to make sure that we're using color in an intuitive way. So it makes it really easy to see that key takeaway from our visualizations. Next, we have privacy and analysis. Have we ensured that data with PII are not used or displayed unless necessary for the analysis? So in addition to just not collecting private information that we don't need, we want to make sure that our analysis outputs aren't inadvertently revealing any sensitive information. And I'll give you an example of this to make this a little bit clearer. Finally, we have auditability. Is the process of generating the analysis well documented and reproducible if we discover issues in the future? So by auditable, we really mean clean, well-documented, and reproducible. If we're working in Jupyter notebooks, we want to be able to restart and run all and get the exact same results. And this makes it easier to address errors if we find them, but also to have fewer errors in the first place because our code is just much cleaner and easier to read. So to give you an example here, I want to talk about Strava. So Strava, for those who aren't familiar, is an app that lets you track your exercise routes. So it uses the GPS on your data to basically capture how far you've run or how far you've biked, and you can share this with friends. And so Strava decided to release a heat map, basically intended as a cool visualization of all the different exercise routes that people had taken. And so this was some 3 trillion GPS data points. But to security experts' horror, this ended up revealing very sensitive information on military bases and spy outposts. And the reason for this is that in areas like Afghanistan and Djibouti and Syria, the users of Strava are almost exclusively foreign military personnel. And so in addition to just outlining where the bases are, it actually went one step further and showed the internal layout of bases, which is something that we can't even see from satellite imagery. So this is a case where we want to be really thoughtful about what does privacy look like, right? How might we actually be releasing sensitive information, in this case, even in aggregate, because there are underlying characteristics where our users in some areas are very different from users in other areas. So moving into modeling, we start with proxy discrimination. Have we ensured that the model does not rely on variables or proxies for variables that are unfairly discriminatory? So here we might not have race or gender in our model, but if we have other variables that are very correlated with, say, race and gender, we're going to end up picking up some of those effects, and that can lead to unfairly discriminatory results. So here we want to think really carefully about what variables are the ones that we're using correlated with, and how might some of these effects that we don't want to be captured actually be sneaking into our models. Next, we have fairness across groups. Have we tested model results for fairness with respect to different affected groups, such as testing for disparate error rates? So there are lots of examples of algorithms that work better for one group compared to another group. And so there are also many different measures of fairness, right? If we're looking at statistical parity or equal opportunity. And so we want to be really intentional here about how are we defining fairness, and then doing that extra work to check, not just looking at the overall accuracy, but how does that accuracy or whatever metric we're looking at differ for different groups in our data. This is related to metric selection, which asks, have we considered the effects of optimizing for our defined metrics and considered additional metrics? So here we want to be thinking really carefully about what does a false positive actually look like, right? What does a false negative look like? And what's the right trade-off there? We want to think through, is the metric that we're using actually optimizing for the things that we care about? And are there additional things that we care about that we're not optimizing for? And so maybe there's a case where we need to bring in additional metrics so that our model is optimizing for that broader set of concerns. Next, we have explainability. Can we explain in understandable terms a decision the model made in cases where justification is needed? Right, so this has become particularly important in healthcare, and I'll give you an example of this in just a moment. Then we have communicating bias. Have we communicated the shortcomings, the limitations, and the biases of the model to relevant stakeholders in ways that can be generally understood? So the point here is that there will always be shoulda, woulda, couldas, right, to your model and your analysis. And without an explicit effort, that knowledge is going to remain on the data science team. And so it's really important to communicate where this model does well, what cases that model struggles under, what are some of the limitations, so that the analysis can really be understood, not just in terms of where it does well, but in context of the limitations. So to give you an example of explainability, I'm going to go back to healthcare. So there was a study done that was trying to identify the risk of pneumonia patients of dying. And so the idea was, if we can associate patients that have a high risk of dying, they can be admitted to the hospital for additional care, and patients with a low risk of dying can be sent home. And so the researchers trained a neural network, and they were looking at the results, and they found that the model predicted that patients with asthma had a low risk of dying. And based on their subject matter expertise, they said, well, this is a really strange result, because asthmatics actually have a very high risk of dying from pneumonia, and so normally they're admitted directly to the ICU. So what had happened is that, given the success of the intensive care unit, the model had learned to associate asthmatic patients with these successful outcomes with having a low risk, when in fact it was because of this additional care that the model wasn't seeing. So without explanatory models, this issue actually wouldn't have been seen. The way that the researchers identified this was through running a logistic regression to understand then the outputs of this prior neural network model. So in cases of life and death, in cases that are really high stakes, we want to think carefully about how important it is to have an explainable model. And there might be a trade-off here, right? There are often trade-offs. And so it might be the case that an explainable model has slightly lower accuracy compared to a less explainable model. But we might want to make that trade-off and say, yeah, we're going to take a 2% hit in accuracy in order to really understand why our model is making the care decision that it's making. So our final section is deployment. And so here we want to think about redress. Have we discussed with our organization a plan for a response if users are harmed by the results? So we want to think through, how does the data science team evaluate cases where there's potential harm, and then how do they update analysis and models to prevent future harm? We want to think about rollback. Is there a way to turn off or roll back the model in production if necessary? Right? We want to have a plan for what would it look like to turn off or to roll back a model if we find that this model is causing active harm. We want to think about concept drift. So this is, do we test and monitor for concept drift to ensure that the model remains fair over time? Concept drift is a little tricky to understand. It basically means, did the statistical properties of the target variable change in unforeseen ways? So it's essentially a measure of, did the world change? And if so, is our model still valid? And I'll give you an example to make this a little bit clearer. And finally, we have unintended use. Have we taken steps to identify and prevent unintended uses and abuse of the model? And do we have a plan to monitor for these once the model is deployed? So there's no way that you can perfectly predict all of the unintended uses of your model. But it is important to think through, right? Are there ways that we can identify or prevent these? And so in one case, there was a really just exceptionally well-functioning text generation model that wasn't released in its entirety because the researchers deemed this as being too dangerous just to release into the broader broader public space. So to give you an example on concept drift, I want to talk about predictive policing. And in predictive policing, the way that this works is that we use historic data to determine where police officers should go next. And so what happens, police officers are sent to a certain area. They tend to find some crime wherever they go, so that crime gets reported back into the algorithm, and then that is then used to determine where police officers should go next. However, what happens is we get this feedback loop, right, where the algorithm's decisions directly influence what data is fed back into the model. So what happens is we end up sending police officers to these same neighborhoods. We send them to a neighborhood, they find crime, the model says, oh, there's crime there, send police officers back. But we've now lost a comparison to say, is there more or less crime in this neighborhood compared to other neighborhoods? So this is kind of the result of this feedback loop. And so we would want to identify this, right? Recognize that we have a feedback loop, and then we can think about what are alternative sampling strategies that we might use to get a more objective view of the crime rates across different neighborhoods. So that's the overview of the checklist, and hopefully some examples that help illuminate where in the process having an ethical discussion might have helped provide a course correction. So to kind of conclude, I want to leave you with this quote by Richard Feynman, who says, "The first principle is that you must not fool yourself, and you are the easiest person to fool." So as I said, this checklist is not going to tell you what the answer is or what is right, but hopefully it gives you a way to try not to fool yourself, right? It gives you a way of seeing what are the different ethical concerns that are arising in the different parts of the data science process, and then it has these prompts that allow you to start having these explicit discussions to think through the trade-offs, the nuances, so that we can be really intentional about the choices that we're making and move beyond just having good intentions to doing intentional work. So with that, I'd like to open it up for questions. So if you haven't sent along questions yet, please do now send them over, and we'll use the remaining of our time to talk about those. So one question that I have is, how was the bias removed from the model in which police were sent to different areas? So here we want to think about, so this goes back to the predictive policing example, right? How do we remove this bias? So the reason why we have this bias is because of our setup, right? Where we're allowing the decisions of where to send police officers to come explicitly from historic data. So there are many different ways we could address this. One way that we could address this is having additional sources of data collection, right? So that we might choose to send police officers to, a random sample of neighborhoods rather than just where we've seen crime. And that's a way to get new data that's not based directly on the predictions from the model, right? And that's a way to make these predictions of where we should, where the crime is highest, because we've gotten a better sample of data. Other questions? Those are all the questions I have so far, so do send them on over. Oh, I thought I saw a hand raise. If you want to say something, also feel free to raise your hand and add a point. So another question, how many projects have you applied these checklists in? Great question. So we actually use this in all of our projects, right? This is part of the way that we set up our projects is that we add the checklist to it. What I find to be really helpful is that when you get in the practice of using this checklist is you start to have these concerns kind of floating in the back of your head. So the checklist still serves as these really important reminders, but when you get used to spotting these different ethical concerns, when you're going through the analysis work, you're already thinking through, all right, what does my visualization look like? Am I clearly defining this, right? Am I being really intentional about the metrics that I'm using? Have I thought about fairness across groups? And that starts to just get integrated, right? You build those data ethics muscles in a way that makes it much easier to use them in practice. Recommendations on where to learn more about this. So definitely check out dion.drivendata.org. This has a lot of the information that I shared today. It has all the examples and more. It'll help you get started with those 2 lines of code, right? Pip install Dion and then output your checklist. We are also not the only checklist tool in this space, right? Or we might be one of the main checklist tools, but we're not the only project with the goal of integrating ethics. into the day-to-day work of data scientists. And so in the slides that will be shared, there's this final slide that has links to other resources that we've seen in this space put up by different organizations. Some are online tools, some are ebooks, and these, I think, will help you get a better sense of just additional perspectives on how we can better integrate ethics into our work. Any other questions? Well, we've got 5 more minutes or so, so I'll hang out here. If you have additional questions, do feel free to just drop them in the chat. There should be a question mark icon on the right-hand side. Happy to address this.
Since there doesn't seem to be any questions, I just wanted to quickly say thank you, Emily, for taking the time to speak to us about really important data science ethical considerations. Those case studies you explained were really interesting, and I have never heard of them before, but very applicable. And we're grateful to those who have attended the session, and we'll provide a survey at the end that we hope you fill out. And we hope you had a great time, and you can stick around if you think of more questions, or if not, we look forward to meeting you again.
Thanks, everyone.